In this video, we'll be looking at how to find the surface area of some very common 3D objects. Now, before we start finding surface area, the most important thing for us to do is really understand what surface area is. And all surface area is the sum of the areas of all the faces. So let's write that down, the sum of the areas of all the faces. So if you can see what each face is, like what shape each face is, and you can find the area of that shape, then half the battle is won. All you have to do is find the area of each face and add them up, and that's all surface area is. So let's look at an example. So here we're looking at a rectangular prism. And if you can see this 3D representation of a rectangular prism well, you'll be able to see that there are 6 faces on a rectangular prism. There is, and I will shade each one, or I'll put a dot at each one as I mention them. There is the left, the right, there is the top, the bottom, and there is the front and the back. Now it looks like I just shaded in the same spot twice, but in the black, that shade represents the front that I'm doing now, and here represents the back. So there are 6 faces, and each face has a partner in a rectangular prism. The left is the same as the right, those shaded blue. The bottom is the same as the top, those shaded red, and the front is the same size as the back, those shaded in black. So now, if you need to find the surface area of a rectangular prism, all you need to do is find the area of each of those faces and add them up. So let's say for example, that this is 6, 4, 5, and 2. All right, so in blue, I'm going to do the left and the right. In red, I will do the top and the bottom. And in black, I will do the front and the back. Now, what did we say or surface area means? Surface area, again, is the sum of all the areas. So when we find each of these areas, we're going to have to add them up. So yes, there is a formula for surface area of a rectangular prism, but chances are, on any quiz, any test, SAT, wherever you're going to need the surface area of a rectangular prism, you're not going to be given the formula. So it is key that you understand this concept. So surface area of the left and the right, let's actually name these length, width, and height. So the surface area of the the left side is our width times, let's point on this, surface area of our left side is our width times our height. It's the same for the right side, the width times the height. There are 2 times that the width times the height shows up. So the left and the right is 2 times width times height, because again, there are 2 rectangles where you have the width times the height. So in this particular example, we have 2 times 5, which is our width, times 2, which is our height. All right, now let's do the top and the bottom. So the top and the bottom are length times width, and also length times width. They're both length times width. So it's adding 2 length times width. So we have here, in this case, 2 times 6, which is our length, times width, which is 5. All right, so that's the top and the bottom. Now we just have the front and the back to do. So the area of the front, or the dimensions of the front, are length times height. And it's the same for the back, length times height. So in order to find the surface area of the back, we're going to have to add 2 length times height. So we have here, in this case, 2, 6, times 2. And that should give us our surface area of our entire figure, which is 104 squared units. So I didn't give you a unit, so let's just say units squared. And area is always measured in squared units. So if you had centimeters, it would be centimeters squared. Inches, it would be inches squared, so on and so forth. All right, so again, this is a formula that would be unlikely given to you in a test or an exam or a quiz. So this is just something that you have to understand. Let's move on to another shape. So now we're looking at a triangular prism. And the concept is the same as the concept of the shape we just looked at. Really, you have to just find the area of each shape. So you have to be able to identify each shape. And once you can find the area of each shape, you add them up. Now, because this is a triangular prism, it's a little bit less predictable. In this particular case, we have on the front, we have a right triangle. But that might not necessarily always be the case. So as long as you know how to find the area of the triangle, which is a face, you find the area of the triangle in that way. And we may or may not have the same rectangle at the bottom, the front face, and the back. The rectangles could be the same, they could be different. In this case, they so happen, as you can see, the dimensions of this one is 3 by 11 in the back. The dimensions of the bottom is 4 by 11 in the bottom. And the dimensions of that front face that's slanted is 5 by 11. So we have 3 different rectangles in this case. But they vary. So I'm just going to show you how I'd find the surface area of this triangular prism. And you're going to need to transfer that knowledge to other triangular prisms. So again, we have our our triangles, which are here in the front and the back. And then we have 3 different rectangles. We have a rectangle in the back. Let's call it back. I don't know. Yeah, sure. Let's call this the bottom. And here's the annoying one. The front face. I'm going to shade it so you can see it. It's tilted. And it's big. All right. So we have that back rectangle, the bottom rectangle, and that front faced rectangle. So let's start off by looking at our triangles, which are shaded red. There are 2 of them, and they're identical. And they're right angle triangles with a base of 4 and a height of 3. So remember, when you're finding the area of a triangle using the formula half base times height, that a base and a height have to be perpendicular to each other. So if we didn't see that they were perpendicular here, we couldn't use that half base times height formula. But they are, so we're all set there. Okay, so the area of each triangle is half base, which is 4, times height, which is 3. That's one triangle, but there are 2 of them, so we'd have to either multiply that by 2, or we would have to add it to itself. So again, half base, which is 4, height, which is 3. So the surface area of the triangle, the 2 triangles, are 12. But that's just the triangles. There are also 3 rectangles. So let's talk about the big one at the front first. Now, some questions would not give you this 5 that they've given you right here. If they don't give you the 5, hopefully you know that you can either use Pythagorean, 3 squared plus 4 squared would give you that 5 squared. Or, in this case, they made it a little easier. It's a Pythagorean triplet, 3, 4, 5. So if they didn't give you this 5, you would not be stuck, but they did give it to you, so we're going to use it. So that rectangle at the front face, which is shaded blue, is 5 by 11. Oops, 5 by 11. Which means that we can easily find the area of that rectangle because the area of a rectangle is length times width. So the area of that rectangle is 5 times 11, which will ultimately give us 55. All right, now we can do the rectangle at the bottom, which is slightly smaller. The dimensions of that rectangle is equal to 4 by 11. And let me just point that out here. 4 by 11. So the bottom is 4 by 11, which means that our surface area here for that rectangle is 44. And we still have the rectangle at the back, which is again slightly smaller. So that's the back. We're looking at this rectangle, the one that's 3 by 5. Sorry, 3 by 11. 3 by 11. All right, so when we do the surface area of that, we get 3 by 11, which gives us 33. So now we have our two triangles, or front slanted face, or bottom, and the back. And again, remember that surface area is just the sum of all the areas. So we're going to add that up, and our overall surface area will be 144 centimeters squared. 144 centimeters squared. Okay, so now we're looking at a square base pyramid. And that's made up of a square at the bottom and 4 triangles attached to the sides of the squares. So in this particular example, we were not given the height of each triangle. So we have to find it. We were given the height right here of the entire figure, which is different from the height of each triangle. So the height of each triangle, let's look at the triangle on the right side, would be that line. That's the line that we're looking for, the height of that triangle. So in order to find that, we have to create an imaginary triangle inside our figure. So as you can see, we know the height of the entire pyramid. That's 3. We can easily figure out this length because it's half of the length of the square. In this case, it's 2. And then the hypotenuse of that imaginary triangle that I just drew would give us the height of the triangle we actually need. So again, the height of the entire pyramid is 3. Going across is 2 because it's half of our 4 here. It's going from the middle to the end, so it's 2. We just created a right triangle. So now if we find the hypotenuse of that right triangle, it would give us the height of the triangles that we need. It would give us the length right here, which is the height of the triangles that we need. All right, so let's do it. Pythagorean theorem says that 3 squared plus 2 squared will give us, let's call it little h squared. All right, so then we finish that off, and we get that 13 gives us h squared. And so that the height of the triangle we need is root 13. All right, so let's keep that in mind and finish the rest of the question. All right, so we have a square at the bottom. That's 4 by 4. And we have 4 triangles. Let's just draw them really messily. Right here, old school. All right. The base of each triangle is 4. The base, let's look at the triangle on the right. The base is 4, and the height of the triangle is root 13. The base is 4, the height is root 13. So let's label that in here. Base of 4 and height of root 13. All right, and if you want to work with a decimal, that's fine. The decimal is approximately equal to 3.61. So we'll work with that. All right, so the area of our square is 4 times 4, because any area is length times width for a rectangle or a square. So 4 times 4 will give us 16. The area of each triangle is half base, which is 4, times height, which we found out to be 3.61. However, there are 4 of these triangles. So we could say this plus itself, plus itself, plus itself, plus itself, 4 times. Or we could just take whatever we get here, and since there are 4 of them, we can multiply by 4. So those are the 4 triangles that calculates the 4 triangles. And of course, we have to add what we did earlier, which is the rectangle, the 4 by 4 rectangle, or square, sorry, in this case. So, or 1 square plus or 4 triangles. All right, and when you calculate that, you should get 44.9 approximately centimeters squared. So here it starts to get a tiny bit harder. So far, all the shapes that we've done have 2D rectangles and 2D triangles, and we're able to figure things out by just finding the area of each of these shapes and adding them up. Now our figure or cylinder has a curved surface that is not quite as straightforward as finding the area of a rectangle. So in this case, for most classes, if you need this formula, it would probably be given to you. So the surface area of the curved part of the cone, of the cylinder, sorry, is equal to 2 pi RH. All right, so what that means is that they're just giving you the area of this curved part right here, and nothing more. So imagine a toilet paper roll that's empty. A toilet paper roll that's empty has nothing on the top, nothing on the bottom. You can see straight through it. That's what that is giving you the surface area of. Now, if you if you're thinking of more of a can, you're going to have to adjust the surface area to add on a top and a bottom, or even a cup. If it has a bottom, you're going to have to adjust that surface area as well. Now, let's pretend that our cylinder is open like the toilet paper roll. All right, so we're going to say that the surface area in this example of our open cylinder is equal to 2 pi r, which in this example is 3, h, which in this example is 7. So in this case, we get 42 pi. All right, but that's the open cylinder. That's our toilet paper roll. Now, let's give it a bottom. Only a bottom. Now, if it has a bottom, let's just say surface area with bottom, the shape of the bottom, what is that? Well, if you're seeing a circle, you are correct. So that means if it has a bottom, you have to add the area of that 2D circle onto your regular surface area. So now with a bottom, it becomes 2 pi RH plus, then we have to add the circle for the bottom, pi r squared. So in this example, 2 pi 3, 7 plus pi, radius is 3 squared for that circle added to the bottom. That gives us the circle. All right, great. So we get 42 pi plus 9 pi, which gives us 51 pi. Now, our third case scenario is if it has a top and the bottom, like a closed can. So if it has a top and a bottom, there is a circle on the top and the bottom. There are 2 circles attached to our cylinder. So the surface area of the completely closed cylinder would be equal to 2 pi RH plus 2 circles, which is 2 pi r squared. We're adding those 2 areas of those 2 circles, which gives you 2 pi 3 times 7 plus 2 pi 3 squared. Again, we have 42 pi, the regular part of our cylinder, plus 18 pi, and in all, that gives us 60 pi. And our units for all of these examples, of course, are inches squared. Inch squared. Ah. All right. Great. Okay, so now it's time to look at a cone. And the cone has some similarities to the shape we just did, the cylinder. Because we have to consider if there is a circle on the top of that cone or if there is no circle. So first I'll give you the surface area for the curved part. And by the curved part, I mean this part. So if you're actually eating ice cream, it's the part that you're eating, not the ice cream itself, but the cone. So that's the ice cream cone. Nothing is on top. That's the curved part, and that's the part you get the surface area of. All right. So the formula for that would probably most likely be given, unless you're told you have to memorize it. And the surface area for the curved part of the cone would be equal to pi r L. So we haven't seen L too much, and L is very unique to this shape. L is the slant length. So it's like you have a ruler and you're measuring the cone from its tip to the circumference of the circle. So you're going from here to here and you're measuring that. That's our L. However, oftentimes they give you the height, which is different from the length. In this case, they've given us that the height is 4 centimeters. So that's the vertical height. But we need the slant length in order to figure out the surface area of this cone. Well, fortunately, we have a nice Pythagorean triplet here, 3, 4, which means that our length would have to be equal to 5. Or if you're not sure about that, you'd want to do Pythagorean theorem. 3 squared plus 4 squared will give you that length squared. All right. So now that we know our length, we're able to find the surface area of our cone. It's pi r, which we actually know that r, so let's put it in. R, which is 3, the radius is 3, and our L, which is 5. Do not put 4 there. It's not the vertical height, but the length that should go there. So our surface area of our cone is 15 pi. That's an open cone. That's a cone with nothing on top. Let's say you want to cover your cone for some reason. You don't want anybody to see inside your cone. It's a secret. All right, so you have to put a circle on top of that cone in order to close it. All right, if we're putting a circle on top of our cone, so it's closed, that means we're going to have to account for that area of that circle. So it's pi r L plus pi r squared. Now, that would give us pi times 3 times 5. Pi r L is 5, 3 and 5, plus pi 3 squared. That's 15 pi plus 9 pi, which gives us 24 pi. And in this case, our units is centimeter squared. Okay, so now we're going to look at the surface area of a sphere. Now, a sphere is just a ball, a 3D shaped circle. So let's say the radius of this sphere is 5 centimeters. It would actually take 4 circles with the same radius to fully cover our sphere, which kind of tells us what the surface area of a sphere is. The surface area of a sphere is equal to 4 pi r squared. So in this particular example, it's 4 pi times our radius squared, which would give us 100 pi. And again, our units are centimeters squared. Okay, so we can do some interesting things to a sphere, like we could cut it in half, right? Think of this shape, a hemisphere, as half a sphere, or just visualize it as a bowl that looks like half of a ball. So our hemisphere, like our bowl or open half sphere, would just be 2 pi r squared. It's just half a sphere. So let me write that down here. Hemisphere, half a sphere. All right, so that's the bowl. That's the open bowl. But let's say you don't want any germs to get into your bowl. You want to cover it up. You take it, you cover it up with a saucer or something. Or maybe you cut maybe an orange in half, and so the entire thing is covered. So now, if this is covered, we're not just looking at the 2 pi r squared below, we're also going to add a third circle on top. So if your hemisphere is closed, so hemisphere closed, you're going to have 3 pi r squared. So it's the hemisphere plus another circle on top. So in this particular example, let's say our radius is still 5. R equals 5 centimeters. And we want to find the surface area of, let's do first an open hemisphere. So the open hemisphere would be equal to 2 pi 5 squared, which would give us 50 pi centimeters squared. And that's for the open. So that's if it doesn't have a top. Now if we close it and we put that third circle on top, we would have a surface area for our hemisphere as 3 pi 5 squared, which would just give us 75 pi centimeters squared. And that's how you find the surface area of all those figures. Thank you for staying with me through this long and tedious process. Good luck.